Since electricity and magnetism are so closely related, and since they occur together, we often refer to this as just electromagnetism or electromagnetic force. Here we see a picture of a wire piercing some kind of horizontal surface, and iron filings have been spread on that blue surface. There's a current running through the wire, and so the wire becomes an electromagnet. And we've seen already that iron filings will align themselves along magnetic field lines. So, how would you describe the shape of the magnetic field that's formed around the wire? Well, the shape is that it's a bunch of circles, what we would call concentric circles. It's a bunch of circles, and each one is wider than the previous one. So it's circles in circles in circles in circles around that wire. Since this wire is producing a magnetic field with concentric circles, we know something about the magnetic field, but we don't know the direction of the field, right? On a magnet, if we had a bar magnet, we would know that the direction of the field goes from the North Pole to the South Pole. The direction of a magnetic field is always determined by which direction a monopole, a north monopole, would move if placed inside that field. So field lines can't just be circles, they have to be circles with direction. If you were drawing these field lines, you wouldn't just draw concentric circles, you would have to draw arrows going around the circles. So in this image, if the electrons are flowing upward, in what direction outward from the wire do the magnetic field lines point? This is where we use the right hand rule. So if you take your right hand and you point your thumb, like if you point your thumb in the direction that the current is flowing, and then you wrap your fingers around to make a fist, your other four fingers, then the direction your other fingers are pointing is the direction of the magnetic field. That's one version of what we call the right hand rule. If an electron moves from left to right, creating a magnetic field around itself, do the same thing. Use the right hand rule. Point your thumb in the direction the current is going. And here you have to remember that it's the direction the current is going, not the direction the electron is going. So if the electron is going left to right, that means the current is going right to left. So you point your thumb from the right to the left, and you wrap your fingers around to make a fist, and the direction your fingers are pointing is the direction that the magnetic field forms. If you imagine that the electron is moving if the electron is moving left to right on your screen, then you hold up your hand, point your thumb from to the left, because that's the direction the current is going. Wrap your hands around, and then the magnetic field, the direction of the magnetic field lines, would be pointing into the screen, not out of the screen.